So I'll explain how the optimized engine works. First of all, I'll identify some key parts of the system. We have here combustible plus air. Combustible is fuel, air is atmospheric air. Number one is high pressure steam. It's basically water evaporated in high pressure, the above critical point. Number 6, it's a low pressure drum. That's liquid plus steam tank. Number 10 and number 5 are two heat exchanger. Each basically exchange the heat from one fluid to another in two pieces. Number 3 is the engine block. Number 4 is the system that cools the engine block. And number 20 we have 4 combustion chamber in the engine block. So the mixture, fuel and air, are fed in combustion chamber. In the combustion chamber, just after the compression in stroke, it reacts, increase the temperature, increase the pressure, and creates the work in the piston that makes the engine rotate. After that, the exhausting gas, basically CO2, water, and the combustion that's not reacted, and the air that's not reacted, is exhausted. Basically, that's a reference engine. The combustion, the fuel plus air, the combustion chamber, the exhausting gas, all of that working in a engine block with a cooling system. That's a reference engine that we can find in any car or any diesel generator. What is made different in this invention? We use some of the heat released with the exhausting gas, that's which is in a very high temperature. We use this high temperature to recover the energy. So in a reference engine, these gases are released to the atmosphere in high temperature. In this system, we use this high temperature to recover this energy, and it's released just there after that in the 26 in low temperature. So part of this heat exchange heat with the liquid, and this liquid that is warm is evaporated and became a high temperature steam. So the number 23 is basically the exhausting gas in lower temperature. It's passed through another heat exchanger, number 5, which recovers the heat that's still in the exhausting chamber, and the 24 pump is the exhausting gas in a cooler temperature. After that, it mixture with this gas, this steam that comes from the 6. We have here gas, they are mixed together and then pass through line 25 and bubble in the gas washer number 15. It passed through a column of water that use it to recover some water created in the combustion and to remove some solid particles that sometimes came with the gas, and then it's released cleaner in the 26 to the atmosphere. This 35 is basically a system to keep the level of the 15. So this 15 washes the gas and recovers the water that is created by combustion. So this is one of the invention, this energy recovery system. Another part of the invention is a secondary invention, that is the gas cleaner, gas washer. Well, number 6, use it to feed number 1. But here we have liquid that goes in the pump 12 in the line 33, pass through this heat exchanger number 10, and the energy that comes from the exhausting gas is enough to evaporate this liquid and to make it high pressure steam number 1. So this number 1 is high pressure steam that comes from the number 16, and it's evaporated by the number 8 heat. Basically, the exhausting gas is evaporating water to the number 1. This number 1 feeds the combustion chamber, each of the combustion chamber, with a spray, a high pressure spray that's released just before the reaction, the chemical reaction. That's another invention. This spray does not exist in a reference motor. So the last invention is the number 6. That's just the liquid is sprayed in the combustion chamber just after the chemical reaction. So it's low pressure spray after the chemical reaction. Actually, it's just after in the beginning of the expansion stroke. After that, it's mixed together in the exhausting gas and passes through all that. And then number 5 is basically the liquid that comes from the low pressure drum, pump in number 13, that covers some part of the exhausting gas heat, and most of the heat is recovered as gain is obtained in the cooling system of the engine block. Another important thing is when the exhausting gas is released from the combustion chamber, it has some pressure, but it's actually low pressure. That's not enough to pass through these 2 heat exchanger and release to the atmosphere. So it was created an ejector. This line 32 is basically steam, low pressure steam with high speed. High speed reduces the pressure. With the reduction of the pressure in the ejector, it increases the difference between the pressure in the combustion chamber and the intake of this ejector. It helps the exhausting gas to go outside the combustion chamber, which make it cleaner for the next 4-stroke process. Another thing that it was calculated but is not proved yet, is not necessary to feed water in the system. The whole system is self-sufficient in water, and all the losses eventually made in the sprays are recovered in the gas washer. Another comment is the figures number 2, 3, and 4 reference engine. The second one I just forgot, and the optimized engine. We have here the angle, the angle of the piston, and here we have pressure. So pressure and angle. Figures 5 to 7, we have the angle and the temperature in Celsius degrees. I think it could help to understand how this whole system works.